Greetings, students. Today we're going to discuss the Semester 2 exam review for Algebra 2. Let's begin. Question 1. So here is a prism, rectangular prism. The volume of said prism is given, as well as the area of the base. So remember, volume of any shape, or I shouldn't say any shape, but a volume of a prism or a cylinder is equal to the area of the base multiplied by the height. So in essence, what I'm asking you to do here is to divide the x plus 10 into the volume, because the height will be the volume divided by the base. Well, how do we do this? Well, we're going to start off by factoring the volume here. So we're going to make the negative 60 into a 4. We're going to find the factors of negative 60 that make 4, in other words. So most people would start off with a 10 and a 6, which is the proper set, because 10 minus 6 is 4. So 10 and negative 6 are my factors here. And we're also going to factor that x squared plus minus 36. That's a difference of squares, so it'll be 6 and negative 6. So this numerator, this volume here, will factor into an x minus 6 times by an x plus a 10. And the denominator here, so in other words, this came to here. And the denominator is going to be an x minus 6 times by x plus a 6. Difference of squares. So these x minus 6's will reduce. They're in the top and the bottom. And then I'm going to divide this by x plus 10, because my area of my base is x plus 10. So that will eliminate it. So that's going to eliminate that x plus 10. So I'm going to divide this by x plus 10, which will eliminate this x plus 10, leaving me with my answer, which is 1 over x plus 6. In other words, 1 over x plus 6 multiplied by x plus 10 is x plus 10 over x plus 6. Next question. Question 2. Identify the x values for which the expression is undefined. An expression is undefined when you divide by 0. So asking, when is the denominator equal to 0? Well, on this one here, x plus 2, if I set that equal to 0, x cannot equal negative 2. X plus 2 cannot equal 0. So I take 2 away from both sides. X cannot be negative 2. And then I also have to factor this one and see if there's any new numbers there that would make the quadratic into a 0. So I'm going to take the 8 and try to break it into a 6. So the 8 to make 6, most people here would start with a 4 and a 2, and that's the proper set. So I also have the factors here of x plus 2 times by x plus 4. So x plus 2 cannot be 0. I already solved that. X cannot be negative 2. As well as x plus 4 cannot be 0. So x cannot be negative 4. So my answers here are negative 4 and negative 2. And I can verify that those are the proper answers by subbing them in. If I put negative 4 in for x on this second fraction, 16 minus 24 plus 8 is in fact 0. So that tells me that it's a 0 in the denominator, which is undefined. Next question. Combining like terms. We have to get the numerators to have the same denominators here, so we're going to, in essence, multiply diagonally. It's not a cross multiplication because there's no equal sign. We're going to multiply the first fraction by x plus 2 and the second fraction by x minus 3. That's going to make our denominator. You see how they're all x minus 3, x plus 2. That's going to make our denominator x minus 3 times x plus 2. So in the numerator here, I'm going to distribute 2x times x. That's 2x squared. 2x times 2 is 4x. 3 times x is 3x. 3 times 2 is 6. X times 4x is 4x squared. Now, if that's a minus sign, which it is, it's going to be minus 4x squared because we have a minus in front of that. Now, I can put a parenthesis here and put it all in the parenthesis and then distribute the negative, or I can do it as I'm going along. It's entirely up to you. So that's a minus 4x squared because 4x times x negated. Next item here, x times negative 1, that would be negative x, but it's negated, so it's actually positive x. Next item here, negative 3 times 4x is negative 12x, but it's negated, so it's actually positive 12x. And the final item here, negative 3 times negative 1, that's positive 3, but it's negated, so it's actually negative 3. In essence here, all you really have to match is the last number. You see how they all have different finished numbers at the end, different constants. 6 minus 3 is 3. So this is the proper answer. I can verify it's the proper answer by matching the rest of the numbers. So 2x squared minus 4x squared, yeah, that's negative 2x squared. 4 plus 3 plus 1 plus 12. 4 plus 3 is 7, plus another 1 is 8, plus 12 is 10. Plus 12 is 10, no, plus 12 is 20. So here is in fact my proper answer. Next one, the perimeter of the figure is 24 feet. So the four sides add together to make 24. I'm asking you to solve for x. So I can put these values in for x and I can see what the side lengths would be. So if x was 3 here, 40 divided by 4, this would be 10, and 18 divided by 3 by 6. So if this was 10 and 6, I would have 10 plus 10. So I'm doing perimeter here, plus 6 plus 6. 20 plus 12, well, that would be 32, my perimeter. I don't want 32, I want 24. All right, so moving along, so I don't want 10 and 6. Moving along, if x was 9. If x was 9, 40 divided by 10 is, that's 4. 18 divided by 9 is 2. So this would be 4 by 2 now. So I'm going to do 4 plus 4 plus 2 plus 2. 8, 10, 12. That would give me a perimeter of 12. I don't want 12. I want 24. If x was 12, this would be 40 over 13. And this would be 18 over 12. And if x was 15, this would be 40 over 16. And this would be 18 over 15. So let's figure out which of these is the proper number. Now is when a calculator would come in nice, because we're doing fractional addition. So like we said, if x was 12, this would be 40 over 13. 40 over 13 plus 40 over 13 plus 18 over 12 plus 18 over 12. I'm looking for an answer of 24 feet for my perimeter here. No, 9 feet. All right. And then if x was 15, it'd be 40 over 16. And then 18 over 15. That's 7 4/10. So, obviously I've made a mistake. Working through my question here. Let's see if we can find it. So if x was 3, 40 divided by 3 plus 1, 40 divided by 4 is in fact 10. 10 plus 10 is 20. 6 plus 6 is 12. Didn't make a mistake there. If x was in fact 9, 40 divided by 10 is 4. 18 divided by 9 is, well, that's 2. So that would be 12. So I didn't make a mistake there. And then these ones here, I added the fractions together. If x was 12, 40 divided by 13 is decimal. 40 divided by 13 is a decimal. 18 divided by 12 is also a decimal, and 18 divided by 12 is also a decimal. So in fact, on this review here, none of these answers are proper. On the test, you don't have this issue. On the test, the question works out properly. So on the test, expect for there to be a proper answer here on number 4. So here I'm just going to pick none of the above. Would be letter E, none of the above. But on the test, expect one of these answers to be the parameter. One of these ones will work out. Specifically, one of these two integer answers will be the proper answer to work it out. Anyways, moving along. So there is a little bit of a linguistic error on this question 5. Same thing on the final exam as I looked at it. It says solve inequality, but it's actually an equality. Solve the equation is what it should say. It's an equal sign, but that's not here nor there. We're going to multiply here across, basically diagonal multiplication. It's not really a cross multiply. You could say it's 4 over 1, and it's 1 times x. So we're going to take 4 times x plus 3. Remember that distributes into the x plus 3. So that becomes 4x plus 12 equals x. So 4 times x, 4 times 3, 4x plus 12. Taking 4x from x yields 3x, and that's negative. And dividing negative 3 into 12 yields negative 4. Negative 4. You can verify your work very easily. Put x in, negative 4 divided by negative 4 plus 3, which is negative 1. So negative 4 divided by negative 1 is positive 4, in fact. All right, next question with the sightseeing boat. So the boat travels at 25 miles an hour. That's its speed. In a calm lake, that's what it goes. Now, if it's going up a river, the stream is pushing it down. It's pushing against it. If it's going downstream, the stream is pushing with it, making it go faster. So it says here, the same boat is used for sightseeing on the river. In the river, the boat travels 6 miles downstream. At the same time, it travels 4 miles upstream. 4 miles upstream. So in other words, we are going to take a certain speed, the current speed, away from, as well as added to, my boat's speed, which is 25 miles an hour. And when we divide the distance over the rates, they should be the same. Once we get the miles per hour or modified, once we modify the miles per hour. So this is my proper equation. I'm taking away from the miles per hour the rate that the boat is traveling. 25 plus c and 25 minus c. C being the current. And this will give me my new speeds. So in other words, if maybe the stream is going at 5 miles an hour, then this will be 20 and this will be 30, and these will be the same. Because the distance divided by rate should be the same time. In other words, d is equal to rt. And what I have here is I have both of these solved for time. Distance divided by rate. Time is equal to rate distance over rate. Distances being 6 and 4, and the rates being 25 plus the current, 25 minus the current. Moving along. How many solutions does the equation have? X minus 6 plus 4 is equal to x over x plus 4. With this question, I'm not asking you to solve it particularly, but I was thinking about this, and I can't think of a way to do this without actually solving the equation, without actually doing the solutions. So that's what I'm actually going to do. I'm going to solve it. Now, there might be a way to do this without actually solving, but I couldn't figure that out. So this one here factors into x times by x plus 4. So it's got the x plus 4. This one only has the x plus 4. So I'm going to take this fraction and multiply it by x, top and bottom. That way it's got everything that this fraction has. And I'm going to take this fraction and multiply it by x and x plus 4. So in other words, on the left here, I'm going to have x minus 6 plus 4 times by x and x plus 4 is equal to x times x. And since the denominators are all the same now, the denominators are x plus 4 times by x, I can ignore the denominators. I've in essence cross multiplied here, if you want to call it that, with the denominators being the same now. Anyways, so I'll distribute this through. x minus 6 is equal to 4x, or plus 4x squared, plus 16x is equal to x squared. I'll take the x squared from the 4x squared. I'll combine the x and the 16x. 4x squared plus 16x minus 6 is equal to nothing. And then I'll look at this and I'll ask myself, how many solutions does this have? Well, it's a quadratic, so it should have 2 solutions. And I also have to ask myself, is either of those solutions a vertical asymptote? In other words, is either of those solutions undefined? So I should probably look at this and ask myself, how does this factor? So the 4x times the 4 times the 6 is negative 24. I'm trying to make 16 from the negative 24. So I'm looking at that 24 and I'm thinking, well, 24 and 2 would make 22. 8 and 3 would make 5. So I don't have a proper set of factors here in order to factor this. So the test question is slightly different here. It is going to be factorable, the test question. This one's not. I would actually look at the quadratic formula here. And I can actually do something else here with this too. I can divide both sides by 2 and make this into a 2, a 3, and an 8. Which then it'll be easier to see that it's not factorable. With the 2, the 3, and the 8. It'll be easier to see that way. Anyways, so this should have this one has 2 solutions. That doesn't mean the one on the test does. The one on the test might have 1 or nothing, depending on if it factors and if it cancels out with its factors. All right, next item, what are the vertical asymptotes of the function? That's when the denominator is 0. So I said x squared minus 9 equal to 0. So x squared is equal to 9. And remember, when something squared is equal to a number, you get 2 answers here. You get positive and negative 3. So x cannot equal positive or negative 3. That's what this means. These are vertical asymptotes. X cannot be either of these 2 numbers. Anything but positive or negative 3. All right, next question, log equations. So remember, this is called the base. This 4 is called the base. So this is the bottom base. And this over here is the exponent when it's written in log form. So my answer here is 4 to the 16th. 4 to the power of 16. And there we go. Letter D. All right, moving along. Question 11. All right, which logarithm expression is equal to the log of 16? So the log of 16, I can use a calculator here if I want, or I can use the operations. So the log of 16 is 1.2. So is that the same as the log of 4 times by the log of 2? No. Is it the same as the log of 4 plus the log of 2? Again, we're looking for the log of 16 here. Sorry about the lights. So no. Is it the same as the log of 4 plus the log of 4? So again, we're looking for 1.2 log of 4 plus the log of 4. Looks like it's the same as that. Or is it the same as the log of 4 times the log of 4? No. So what property is this? Well, this is the property that states when you have two things multiplied when you have a logarithm, you can break it down multiplication into addition. Multiplication becomes addition. So the log of a times b is equal to the log of a plus the log of b. But that doesn't mean you have to remember that particular equation. Again, I just typed this in a calculator. I figured out that's about 1.2 log of 16. It's about 1.2. And then this answer here, log of 4 plus the log of 4 was also about 1.2, 1 2/10. So you might want to just do it that way. Remember to use parentheses properly. So you need to use parentheses around the log of 4, the first one, at the end. All right, next item. Solve 4 to the 4x is equal to 16 to the x plus 1. I would change this into 4 squared and then distribute the exponent through if I was working this myself. But that doesn't mean that that's how you're going to want to do it. So what I would do here is I would change that 16 into a 4 squared. And then they have the same base. That 2 distributes. And since the bases are the same, the exponents will be the same. So 4x is equal to 2x plus 2. 2x from 4x is 2x. 2 divided into 2 is 1. What you might want to do instead, though, is to substitute in the values of x and see which one works out properly. So 4 to the 4th, because I got a 1 here, it's going in. 4 to the 4th is 256, and that is the same as 16 to the 1 plus 1 squared, 256. Whereas the rest of these, if I put these in for x, 4 to the 8th, 4 to the 8th is 65,536, whereas 16 to the 3rd is only 4,000. And these fractional ones are not going to work out either when you put them in for x. All right, next item, vertical shift and stretches versus strengths. So first item here is the vertical shift. Which way is it, up or down 2? Well, down 2, down 2. So this is up 2, this is up 2. Neither of those is appropriate. Next item here, 1/4 versus 4x. So is it the fractional exponential function or the integer exponential function? And you can verify this by putting in a value other than 0. Remember, anything to the 0 is always 1. So both of these will be at -1 when I put in 0. So it's not worth my time or effort to put in 0 here. So if I put in 1, the answer should be close to 2. If I put in 1 to this, or -2, sorry. If I put in 1 to this one, it's going to be 4 minus, it's going to be +2. So on this one here, on letter C, if I put in 1 for x, it should be +2, because 4 to the 1st is 4, minus 2 is 2. So if this one, if it was this graph, it would be here. It would have this same value here. It would have the same asymptote, horizontal asymptote, but it would be here and here. Whereas this one, if you put in 1 for x, for the y value, you're going to get off 1/4 minus 2. You're going to get out -1 3/4, which is what we have, 1 with -1 3/4. Because 1/4 minus 2 is -1 3/4. All right, end behavior. Oh, sorry, you couldn't see that I was going through it. I'll put it back up there. Again, it's down 2, the shift. So I crossed out these two because these were both up 2. And then I looked at this point here. If I put in 0 for x, it's going to always be 1. So these two both have the same value at 0. Not useful. So I decided to put in 1 for x. 4 to the 1 is 4, minus 2 is 2. And then 1/4 to the 1 is 1/4, minus 2 is -1 3/4. That's why I picked letter A. All right, next question. Question 14. Describe the end behavior. So as x gets large, what happens to y? Well, as x gets larger, e is about 2. Oh, that's 2.7. But e is about 2. So as x gets larger, y is going to get larger here as well. So as x gets bigger, y gets bigger. So which of these say that? Well, letter A says as x gets bigger, y gets bigger. Letter C says as x gets bigger, y gets bigger. Letter B says as x gets bigger, y gets closer to 4. Y does not get closer to 4 as x gets bigger, because e to a power is like 2 to a power. So if this is power of 1, well, as x increases, as it becomes 2, 3, 4, 5, and 6, this is going to become larger and larger and larger, like 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th. Bigger and bigger and bigger, doubling each time. And the same deal here. So the other thing is, as x gets smaller, what happens to y? Does y get infinitely smaller, or does it approach 4? Well, as x gets smaller, this becomes a fraction. For example, e to the -1 is not a -2, it's 1 over e. e to the negative 2, it's not a negative 2 squared, it's 1 over e squared. It's a fractional value. So this fraction is going to get smaller and smaller in value. In other words, as x gets more negative and more negative. As x gets more negative, the fraction gets smaller and smaller. So the fraction is going to become eventually infinitesimally small, or as small as it can possibly be. That's why it approaches 4 as x gets more negative. All right, moving along. Question 15. All right, function g of x is equal to 1.5 to the x, 1.5 to the x. Find the value of g of 1 minus f of negative 1. All right, so this is f of x on the coordinate grid. So f of negative 1 is the value of the function at negative 1, the f function here, the f function. So that value at negative 1 is positive 1. F of negative 1 is equal to 1, because when x is negative 1, y is positive 1. So this is a 1. G of 1, well, anything to the first is just the number. So 1 goes in for x here. G of 1 is going to be 1.5 to the first, which is just 1.5. So 1.5 minus 1 is just a half. Substituting in the value of x for the g of x function, and then looking at the f of x function and matching the x value with the y value. All right, solve. Notice these are all base 2. Base 2, base 2, base 2. So what that means is, because they're all base 2, I can combine this together into a quadratic. Remember, plus becomes addition, or plus becomes multiplication. And then I can set them equal. So x multiplied by x plus 5 will be equivalent in value to 6. So x squared plus 5x is equal to 6. Taking the 6 from the 5x, x squared plus 5x minus 6 equals nothing. And then factoring this, x minus 1 and x plus 6. Now, why didn't I use 3 and 2 here? Well, because 3 and 2 would make 5 if this was a positive 6. But because it's negative 6, we got to use 6 and negative 1. 6 minus 1 is also 5. So again, if that's a negative 6, it's 6 minus 1. If it's a positive 6, it would have been 3 and 2. So here I get two answers. I got an answer of x equals 1, and I also got the answer of x equals negative 6. So is x equal to 1, or is x equal to negative 6, or is it equal to both? Well, a logarithm can never be negative inside. So while this yields the answer of negative 6, this equation does, this logarithm cannot be negative inside. So negative 6 is not appropriate as an answer. Only positive 1 is appropriate. Using the change of base theorem, I can verify that this is in fact properly done. So if I take the log of 1 divided by the log of 2, log of 1 divided by log of 2, and I add in the log of 6 divided by log of 2, I'll get, well, that's 0. That's convenient. And I'm going to get then I'll take this one, log of 6 divided by log of 2, which is 2 and 5, 5,800. So what mistake have I made here? Log of 1 divided by the log of 2 plus the log of 6 divided by the log of 2. No, I typed the first one in wrong for somehow. So log of 1 divided by log of 2, log of 6 divided by log of 2 was in fact 2 and 5,800, just like the log of 6 over log of 2 is. It is worth your time to go through as you're going through these questions and check your work. You got the whole period to work on this. You just will spend 2 or 3 minutes a question. You got an hour and 45 minutes. So don't try to rush it. I know you want to get through it, but don't try to rush it. All right, so this is my base, this is my exponent. So I'm going to change this into, actually, I don't have to change this into a exponential function to start it out. If I do change it into an exponential function, I'll have to do a cube root, which also is acceptable. So maybe I'll do that. So x plus 1 cubed is equal to 2 to the 9th. So what is 2 to the 9th? 2 to the 9th. That's a 512. Now the issue is, does that cube root evenly? And how do we do a cube root? So if I'm going to take this approach, I'm going to have to actually think to myself, how do I do a cube root? So I showed you this a while back. So 512, if I'm going to do a cube root, I do a 1/3 power. That's the cube root of 512, which is 8. So there's one approach, x plus 1 equals 8, subtracting 1 from 8, x is 7. Another approach here is to take this exponent into the front and divide it over. So this 3 can come into the front, and I could write this as the log base 2 of x plus 1 is equal to 3. You see what I did here? I took the 3 in the front and divided the 3 into the 9. And then I would just do 2 cubed and add 1 to it. 2 to the third is 8. Subtract 1, sorry. Subtracting 1 is 7. And a final approach here would be putting the 7 in for x and evaluating this logarithm using change of base. Moving along. Question 18. Convert radians into degrees. So we're timesing by 180 over pi. The pi's will cancel because they're on the top and the bottom. So I got 15 pi divided by 4 times by 180 divided by pi. Whoops, and I typed in some extra stuff there. 15 pi divided by 4 times by 180 divided by pi. That's what I wanted. 675 degrees. The exact value of the sine of 4 pi over 3. All right. I'm in radian mode right now. That's a radian measurement. So the sine of 4 pi divided by 3 is negative 86 hundredths, 87 hundredths. So that's not a negative half. That's not a positive half. That's not a positive square root of 3 over 2. That's a negative square root of 3 over 2 in value. All right, moving along. And we're back. What are the coordinates on the unit circle that correspond to the angle? So I look at this and I say, that's a half. So the cosine of my angle should be a half. So I can take an arc cosine of a half. And I can give myself a degree measurement here. If I'm in degree mode, right now I'm in radian mode. I prefer to work in degree mode with this type of question. Arc cosine of a half, 60. So this angle is a 60-degree angle. I want this angle, however, to be in quadrant 4. So in quadrant 4, what is the equivalent of 60 degrees? How do you get that reference angle? Well, you do 360 minus. So this is 300 degrees. And you can verify that the cosine of 60, which is a half, is in fact the same as the cosine of 300. Cosine of 60 is a half. Cosine of 300 is also a half. Yeah. So my angle is 300 degrees. I did ask for the angle in radians, so I'm going to times it by pi over 180. So 300 divided by 180, and I'm going to reduce that fraction. It's 1 and 6 tenths, or 1 and 67 hundredths. So when that's rewritten as a fraction, it's 5/3, 5 pi over 3. My angle is 5 pi over 3. And I can go back here, and I can actually work the question backwards in radian mode as well. So in radian mode is the cosine of 5 pi divided by 3, 1/2. Yes. Is the sine of 5 pi divided by 3 the negative square root of 3 over 2? Yes, negative 0.866. Whereas if I type in the other values here, the cosine of 4 pi divided by 3, that is not going to be a half. That's a negative half. And the sine of 4 pi divided by 3, that is negative square root of 3 over 2. And the cosine of 11 pi divided by 6, 0.866. The sine of 11 pi divided by 6, negative half. Cosine of 7 pi divided by 6, negative root 3 over 2. And the sine of 7 pi divided by 6, negative half. All right. Which value has the same value as the cosine of negative 60? Again, same concept. Back to degrees. Cosine negative 60. That's a half. A positive half. So with the negative cosine of 30, a half. Nope. That's square root of 3 over 2, negative. Is the sine of 30 a half? Yep. That should be my answer then. Is the negative cosine of 60 my half as well? Nope. It's a negative half. And is the negative sine of 60 a half? Nope. That's the negative square root of 3 over 2. Again, you don't have to rush through these. Try all four of them, see which ones of them work. It's more useful to you in terms of time to just try the question appropriately all the way through and do the question, then to come back to it later and redo it again. Do it properly the first time around if possible. Just take your time. All right, minute hand on a clock is 6 feet long. 6 feet long. That is a big clock. That's like Big Ben in England. That is a big clock. To the nearest foot, how far does the tip of the minute hand travel in 150 minutes? So S is equal to R theta. Arc length equals the radius times the angle. Theta must be radians. So the radius here is easy to identify, 6 feet. So that's a breeze, 6. The theta, not so much, 150 minutes. Let's convert that to degrees first. So how many degrees per minute does a clock go? Well, in 60 minutes, it goes 1 rotation. So in 60 minutes, it's 1 rotation. So 360 degrees per 60 minutes. That's the what's called rotational velocity of the clock, or how fast the clock goes. So in other words, the clock goes 6 degrees per minute. 360 divided by 60 is 6. 6 degrees per minute. So I'm going to take my minutes, I'm going to times them by 6. 150 minutes multiplied by 6 degrees. Now that's going to give me my angle in terms of degrees, not radians. So I'm finishing this out, I'm going to times by pi over 180 to make my angle into radians. Now the pi is going to be left in the finished answer. So I'm only going to multiply the 6, the 150, the 6, and then divide by 180 here. 6 times 150 times 6 divided by 180. 30 pi feet is the distance that this clock has traveled. All right, in which 2 quadrants is tangent positive? Now, again, you can use a calculator on this if you want, or you can remember all students take calculus. So all of them are positive in quadrant 1. Sine is positive in quadrant 2. Tangent's positive in quadrant 3. And cosine's positive in quadrant 4. So quadrant 1 and quadrant 3, all students take calculus. Or you can verify this with a calculator. Is the tangent, and let's go back into the degrees, so between 0 and 90. So is the tangent of this, for example, 45 positive? Yes. And then I can test that angle in quadrant 2. So is the tangent of 170 positive? No. 170 is between 90 and 180, so that puts it in quadrant 2. Is the tangent of 190 positive? Yes. 3 tangents positive. And is the tangent of, for example, 350 positive? No. So you can test the quadrants individually, or you can remember all students take calculus when we went over this together. All right, and last 2 questions for today's video review. I'm only going to go through the first 25 on this one. I'll do the other 25 on the next one. 24 and 25. A rectangle is inscribed in a circle. Each vertex lies in a different quadrant. One vertex of the rectangle is given. What are the answers in quadrant 4? So which of these points is in quadrant 4? So this is in quadrant, well, positive and then negative. That's in quadrant 4 because x is positive, y is negative, right? Quadrant 4. Negative, positive, that's in quadrant 2 because x is negative, y is positive. Negative, negative, that's in quadrant 3. Negative, negative, that's also in quadrant 3. So which of these is in quadrant 4? Positive x, negative y. Not much to remember there. All right, which function has an amplitude of 4 and a period of 2 pi? So amplitude, again, is the number in front of the function. Boom, 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 boom. This is an amplitude of a fourth. This is an amplitude of a fourth. These both have amplitudes of 4. And then periods, well, for sine, the period is 2 pi divided by b. For tangent, it's pi divided by b. So 2 pi divided by b versus pi divided by b. So this one has a period of pi. This one has a period of 2 pi, like I want. Question A. Anyways, I'm hoping these video reviews will help you out. I know I'm not particularly good at this. But if you do have questions, come on in after school. Before school, I'll be here. Try to give you a hand on these first 25, and I'll put up the other 25 sometime again this week. Good luck.